Right, so in this first example of how we vary rate, we're going to look at the surface area. So the surface area is going to be related to the reacting surface of a solid. So we're going to look at how changing the surface area of two substances can affect the rate of the subsequent reaction that you would see. So what we'll do is we'll take two identical beakers and place them side by side. And what we'll do is we'll place a solid into each of the beakers. So in the first beaker, what we'll do is we'll place a 4 by 4 particle of solid. So we'll have a 16 particle diagram there of a solid. And we'll have just in there, we'll have one reacting particle. Well, now we'll imagine this is a solution, so we'll imagine obviously that it's full of particles, but to simplify the diagram, we'll just have one reacting red particle there, and we'll do exactly the same thing in the other one. We'll have the same red reacting particle, but this time instead of having what's essentially a 4 by 4 particle diagram there, we'll chop it up and we'll split up the 4 by 4 pieces of solid into four 2 by 2 particles. And what's important to see is we've got the same number of particles in each diagram. We've got 16 blue particles. We've got 16 blue particles in both diagrams, and we've got the one reacting red particle. And what we can see diagrammatically is that the particle which is going to react, so for example, we'll say that one there, and we'll say that one there. As we've just said, they have to collide. So it is possible for the red particle to collide with the blue particle. Therefore, it is possible for those two substances to react. And what we're looking at now is if we have the ability to affect the number of collisions that can occur, we can then affect the rate of the reaction of two reacting particles. And what we can hopefully see is that if this solid is resting on the bottom of the beaker, it is possible for those four particles to react with those three particles and those three particles there. It's not possible in this diagram for these particles initially to react with the outer particle that's going to collide with it. However, in the other example, it is possible for all of these particles to be hit by the red particle. It can get down between the gaps and collide with every single one of the 16 particles. That will allow for more possible collisions per second, allowing, therefore, for a higher increased possibility of the rate of reaction because of the increased surface area. So here we have an increased surface area on the right hand side diagram. Okay, so this one has an increased surface area, therefore it's possible for the rate to increase because of the increased likelihood of collisions per second between the two reacting particles. And then what we'll do is you can then see that evidentially in reaction, for example, between hydrochloric acid as your solution and calcium carbonate as marble chips. And you can measure that via either measuring the volume of a gas which is given off or by recording the mass loss of the reacting products as that reaction proceeds.